Hello and welcome to the Kubernetes podcast from Google. I'm your host, Kazan Fields, and
I am Abdel Sigiwah. This week, we spoke to Justin Cormack, the CTO of Docker. We talked about WASM, or WebAssembly modules, Docker support for running WASM apps, and the future of the technology.
But first, let's get to the news.
The German version of the Cloud Native Glossary is live. The Cloud Native Glossary is a project led by the CNCF as an effort to make cloud native terms easy to understand without requiring prior technical knowledge. The community is prioritizing localization in multiple languages. The glossary is now available in 10 languages beside English.
The Kyverno project released version 1.10. This is a major release for the Kubernetes native policy engine. New features focus on scalability, extensibility, and security.
ChainGuard moved from GitHub Container Registry to a self-managed one for their base images. The new registry is designed with security out of the box, provide cloud events for pull and push, and is built on top of Cloudflare R2, which has a $0 charge for egress.
Microsoft announced the general availability of its Azure Linux. The Linux distro is an open source container host for the Azure Kubernetes service. The distro is based on CBL, or Common Base Linux, and is designed to have a small footprint. The core image is 400 megabytes in size and has 300 packages pre-installed.
Google's new C3 machine family is available for GKE standard clusters running version 1.22 or later. These new machine types are powered by the 4th generation Intel Xeon Scalable processor, codename Sapphire Rapids, DDR5 memory, and Google custom Intel infrastructure processing engine. The VMs are designed to support network configuration with up to 200 gigabytes per second bandwidth, support Intel AMX for ML workloads, and a whole set of features for security and performance. Check out the show notes for more details.
Amazon announced support for pull-through cache from Kubernetes official registry to the Amazon Container Registry. Customers can configure ACR to pull images from the upstream registry.k8s.io and cache them, removing dependency on external registries for commonly used images.
The Linux Foundation announced WASMCon, a conference focused on WebAssembly technologies. The event will take place between September 6 and 7 in Bellevue, Washington. The call for proposal is open until June 25th. Links for the conference and the CFP are in the show notes.
Cilium announced the general availability of their Intro to Cilium course on the Linux Foundation training and certification website. Cilium is an open-source cloud-native solution for networking, observability, and security. The course introduces the incubating project and demonstrates its features. Check out the link in the show notes for more information. And that's the news.
Welcome to a new episode of the Kubernetes podcast with Google. I am your host, Abdel, and today we have the pleasure to talk to Justin.
Hello, nice to be here in person at KubeCon. It's a lovely time.
Nice, yeah. So we're here at Amsterdam. We're in our office on a Monday. We're recording this, and we are just, I would say, pre-KubeCon chaos.
Yes, just I haven't collected my pass yet. I haven't seen the chaos yet, but probably do that after this.
Yeah, I haven't collected my pass yet, and usually KubeCon is just very, very chaotic. Scott tweeted about the topic we're going to talk about today, and then I tweeted at him, saying like, hey, we'd like to have somebody on the show to talk about it. We have a rule in the show that we don't want to have the same guest twice. So that's why I said to Scott, we want to have somebody else, because Scott was already on the show once. And then he volunteered you, I guess.
Well, it's nice to be here. I can't believe I haven't been on here before,
Oh, yeah.
It's an opportunity.
We've been chatting earlier. We've been at the company for like 7 years.
Yeah.
Well, here we are. So let's start with who you are and what do you do?
Yeah, so I'm Justin Cormack. I'm the CTO at Docker. As I said, I've been at Docker for 7.5 years now. So I've had a bunch of different roles, been CTO for a few years now. And yeah, I mean, Docker's been through a lot of change, but we've really, the last few years, we've really been focusing on the developer story, what's good for developers, how to help developers with better products for them. And that's really my focus.
Nice. We've been chatting earlier that you're also responsible for everything that Docker provides as a service, so everything hosted essentially products, right?
Yeah, we have a mix of products like Docker Engine, Docker Desktop for locally, and we have hosted products Docker Hub and services like Scout for supply chain security and things that we've added.
Yeah.
And really a growing range of services to support you as a developer.
Nice. But so I think Docker is pretty much
at this stage known to everyone who is doing containers. So I think we don't have to expand on the topic of what Docker is, but today we're going to talk about something that we've been hearing about for the last, let's say like a year and a half, maybe 2 years.
Unless you were really early, yeah, that's probably, I think the last year is really when people started saying the WebAssembly word or
WASM.
WASM, its informal name.
Exactly. So let's start with, for those who doesn't know what it is, what is WASM?
So yeah, WebAssembly, there's a kind of long story about WebAssembly. It's all about the browser, and really, for a long time with the browser, people have been trying to work out how to run bigger and more complex code in the browser, and especially things that, it sounds a bit like you don't want to write JavaScript, but sometimes you want to run code that you don't want to rewrite in JavaScript, for example. You've written, say, image processing library or something you want to run in the browser, and you've written it in C++, say, and you still want to run it in the browser. And there's been a long history of ways to do this. I think Google were kind of early in this. I think Gmail was one of the early examples of compiled to the browser.
Native code in the browser,
native code in the browser from Java. And there were lots of projects for lots of different languages around kind of compiled to JavaScript for different languages. And then Mozilla started working on ASM.js, which was a subset of JavaScript that was kind of efficient to do this with and a good target for, rather than kind of generic JavaScript. And ASM.js kind of became WebAssembly. It's like, well, this was a good example. It showed that you could have a faster subset, but making it just JavaScript was kind of difficult. And I think it was the Chrome team and Mozilla came together, I think, originally to work on something that was kind of really specially for that use case as a compile target for any programming language. And so they called it WebAssembly because it's like assembly, because you compile your programming language to assembly when you're compiling it. And it's for the web, so that was kind of where the name came from.
So that's the WebAssembly part in browser. And then what happened in the last maybe year or so is people started saying, like, why can't we take this and just run it outside of the browser, right?
Yeah, and again, there's a long history of taking browser tech and running it outside the browser.
Oh, yeah.
Node.js is probably the original example, but there are others as well. I think a lot of it comes down to the browser security model is like the most heavily tested, security boundary there is, with billions of users and a huge amount of security engineering work being done on that. And so, the argument is always like, well, let's take V8 with JavaScript and use it. So things like Cloudflare workers are based on V8 running, and there's been lots of other examples where it's usually been V8, but sometimes other browser engines, and just taken them and used them for running on a server has, a couple of things really. One is the isolation technology and having that.
The sandboxing technology.
The sandboxing. And then the other is often, providing a JavaScript embedded API for something, or now a WebAssembly embedded API. It's like if you want to embed some JavaScript for scripting in some program, you can do that. But again, V8's a big thing to embed, and it's difficult, and it requires, it's not what it's designed for. It needs a lot of maintenance if you're going to support V8 as part of your application. So the WebAssembly story, again, is part of that kind of story where you take the web technology and you say you want to run this portable sandbox code elsewhere, so you can just take the WebAssembly sandbox piece without the whole of V8.
Yep.
And the WebAssembly sandbox is designed to support, the whole browser sandboxing model and sit, in that framework, and then you could basically run WebAssembly code. That path from browser to server has been done quite a lot of times, but the whole kind of model where you actually have a smaller piece of the browser that just has the WebAssembly without taking the whole thing is easier to maintain.
Yep.
And it's also, people can write any programming language, not just JavaScript. And that's actually a big change as well from, you don't have to think about, like, do I want to use JavaScript, but you can just, a lot of people doing Rust or C++ because there's a lot of legacy code. There's, all sorts of languages getting support now since that's happened.
Yeah, and one thing that you touch on is this concept of sandboxing, which to somebody who's coming from the infrastructure space, the way I can think about it is like, it's really a VM, right? It's kind of like a virtual machine which is sort of like, from an infrastructure standpoint, it's the strongest kind of isolation or sandboxing you can have.
Yeah, I mean, the term VM is kind of used in a few different ways.
Yes.
There's VM in the sense of VMware and the hardware virtualization and that boundary, and then there's virtual machine in the terms of the Java virtual machine. And we tend to call them all virtual machines. When they are virtual machines in the original kind of sense of virtualizing something else. But, I mean, strictly WebAssembly is more like the JVM type of virtual machine than it is. The security boundary doesn't use the hardware virtualization instructions that JEPs have. So it's not the same kind of boundary as you get by having a separate VM. However, it has been designed, to be secure. Everything about the design has been designed to make sure that it is a strong, not a weak boundary. I mean, I think when Java first happened, people thought that Java would be a strong security boundary, but there was, kind of a lot of issues with the design of the JVM and the standard library and how the standard library worked, and it never really got there. WebAssembly's got a lot of lessons learned from the history of how to do kind of pure software isolation. There was another Google project as well that kind of in the history of these isolations was a modified version of x86 assembly with instruction constraints.
Is it not gvisor? Gvisor's containers.
No, earlier than gvisor.
So we'll have to figure out probably there is. I don't know which one.
As I said, there's been a long history of these things. And gvisor is another interesting one because gvisor again it has different implementation backends, but it's it's a software implementation, but at the system call API level, but it has support for hardware virtualization to strengthen the isolation. So, there's a kind of big set of these different isolation mechanisms and, kind of with different strengths. And, it's important when you're using things to think about what kind of security boundary you need, how much. I mean, I think that, when containers started, there was an awful lot of talk about containers versus VMs, which is more secure, things like that. And for most use cases, if you kind of skip over all the history and come to now, we've decided that if you want really strong multi-tenant isolation, containers are not sufficient.
Yes.
But for many purposes, they're absolutely fine. Like they're pretty...
If you don't care about isolation.
If you don't care about multi-tenant, for single tenant, they're fine. And for many users, they're fine. But then we've also worked out that, you can wrap these layers, and the valuable thing is the standardization and the portability of the images and the containers and the APIs. And you can, if you use, something like Google Cloud Run, it's a container as far as you're concerned, but the implementation includes a VM for isolation. So it's a combination of the two. And I think we'll see, a lot of the same thing with WebAssembly. I mean, Google, again, has a published guideline that untrusted code has to have 2 layers of isolation between it and the raw hardware and the host. And so for WebAssembly, one of those layers can be the WebAssembly boundary, perhaps, and then the other one could be, maybe it could be gvisor, or it could be a VM, or or a container. I mean, there's lots of options depending on your detailed security requirements and your these kind of requirements. But there is the security boundary that's come from the browser in there, which we know is a strong one. So we have got at least one strong boundary there.
One layer.
And if you need a second layer, you can. We have a lot of technologies now for building more security boundary layers, but we've got the one, and I think that's one important part of the WASM story. It's not the only bit. I think the other piece is the real portability story that comes with it. WASM can run anywhere. It can run in the browser. It can run on a server. It can run embedded in Istio. It can run
or in a Raspberry Pi or whatever.
Yeah.
Right?
So it's we've got this real portability story that's very, very broad, and a multi-language story as well. With it's not just a JavaScript story that we had with some of these other.
Yeah, you have Rust, C++, but there are also a bunch of other programming languages building their compilers in such a way that you can build as a target or WASM.
Most languages now.
Most languages.
Ruby.
It's 40 plus or something.
JVM. There's all sorts now.
Yeah. So I think we touched on a lot of things, and I want to depict one thing at a time. But just going back a little bit through the conversation, one thing that I couldn't help myself from thinking is And because you mentioned like the JVM and, difference between JVM from a kind of software layer perspective and virtual machines from a hardware layer perspective, it feels like WASM was kind of conceptually a virtual machine, at least from a software layer perspective. But you still need extra stuff if you want it to run as a system component. So if you need to talk to it through like the network, right, or bind it to a port.
Yeah, so, I mean, WASM made it, I think it's part of the learning from Java. With Java, a lot of the security issues were in the standard library code, not the raw JVM code. And I think WASM made a decision that, and it also fits with the web platform model, that you have the VM, but it doesn't natively have the ability to do any kind of output or input or talk to anything else. It's a purely isolated system.
Yes.
But you can add these entry points that you can call to the outside world. And that's how the browser works. When some new bit of functionality is added to the browser, like, WebGPU just shipped in Chrome. So a new API is added for the browser kind of, from the outside world that can securely talk to your GPU. Yeah. And you can then call it from JavaScript. There's a new JavaScript API appears and you can call that. But it's a communication channel between two bits of software, one on the inside of the sandbox and one on the outside. Well, it's also probably in a sandbox as well, but because everything's sandbox. But conceptually, it's just a new place you can talk to. And WebAssembly, has exactly the same model, that it doesn't natively have any APIs you can talk to the outside world, but it has these, has the ability that when you set up the runtime, you can say, like, here are the things in the outside world you can talk to. These are their APIs, and go talk to them and do what you want. So it's in its sort of raw state, it's totally opinionless about whether it's running inside Istio or a browser or a server with some, But when you create it, you decide what's the things I want it to talk to. What's this application use case for? Yeah. And what interfaces shall I give it? And then you decide those. So it's quite a good model because it fits with the security boundary, and there's, it's just a kind of IPC type model usually where it's talking down in the socket, but it doesn't give you anything up front. Yeah.
And so part of that is the effort called WASI, the WebAssembly System Interface, right?
Yeah.
By the Bytecode Alliance, I think.
That's right.
Right.
Yeah.
So WASI is essentially this interface between WASM as the sandbox where your application will run, and the network, the whatever other stuff that needs to talk to, right?
Yeah, it's kind of an interesting thing because it also has a really long history. It actually originated out of a kind of lineage of things a long time ago with FreeBSD and the Capsicum project and various like a standardized system call interface for BSD. And so it basically is a sort of like POSIX-y kind of Unix-y view of the world, but not quite. Yeah. But it's close enough that it's been a target that you can compile, a lot of, standard Unix-y, Linux-y programs to. Mm-hmm. It's got enough of the kind of base system calls that you can basically build a libc that does many things, but it's still evolving. And the first release really had file system calls and the file system interface and a few things like random numbers and time, maybe clocks, things like that. Okay. And not very much for networking.
Yeah, not yet, I think.
Yeah, I mean, technically you can pass in a network socket, I think. But anyway.
Through a file,
But so what's happened is that a lot of people have added their own extensions for how networking should work while it evolves. But the standard's kind of moving into the next version, which will have networking support, because that's obviously been...
that's one of the major things.
It's been a big issue. On a server, you kind of want to do networking. It's useful,
I mean, if you want to bring WASM to the cloud, you need that part, right?
You do, yeah.
And so then talking about that, so you will correct me if I'm wrong, but I think that probably for a lot of people, once they would hear Docker say, like, we support WASM with Docker, the first thing that will pop in their heads, and what happened to me is, let's just take a WASM module and shove it inside the container. And I feel like that's not what you're doing, right?
No, but so there's a number of things we've been trying to do, and and there's a gradual process of things we need to do going forward as well. Yeah. So we've been working with Microsoft and other people on the containerd shim that supports WASM runtimes. So right now, yeah, it does actually, run the stuff in a container but it's not necessary. We can fix that later. It's like just
you can make it run as a standalone binary, essentially, outside of a container.
Yeah, I mean, it's really a runtime. I mean, it's just incremental bits about. I mean, Containerd is a very general tool for running things and managing them and pulling, and in particular taking OCI, Docker images and unpacking them and then handing them to the bit that does the actual run, which normally is runc, which runs containers. But it's a very pluggable ecosystem, and so you can also run the WASI bit, and that doesn't have to run in a container. It doesn't necessarily have to run on Linux necessarily either. Like it's multi-platform, but there's work to be done still to kind of unpack all this and iterate on making it, work fully how we want. So the Docker desktop stuff runs the stuff under Linux, but that's just the things that we need to tidy up. But a lot of the things we want to do was show that you could really have the same kind of workflows with WASM. You could still run WASM with Docker run and have a way that you could uniformly run it. But that doesn't mean that like with containers, when you run them in Google Cloud Run, you don't really know. It doesn't matter how they run. It just runs. And same with WASM. It's about having standards for how it's packaged and the interfaces it has, and therefore you'll know that you're going to be able to run it somewhere. It's not quite 100% smooth like that because of there's different run times that have been, mainly because they have different WASI like networking implementations right now and things like that. So there's
the ecosystem is still quite fragmented.
I'd say, but the model we're working towards is like you can compile your stuff as WASM and you can run it anywhere. That's in the same way you can with containers, because that's I think that's what's going to lead to really wide adoption, is where it's very simple, straightforward, just run it everywhere, just use it as a target, and that gives you that universality of runtime that we have with containers. And
run anywhere kind of model. And so this is, I mean, we have to mention also this is still beta in Docker Desktop 4.15, right? The support is still in beta, so it's still early work that you are, it's ongoing.
We did another release just a few weeks ago as well. So there's with multi-runtime support. So there was a kind of beta 2, the other in 4.18 as well. So we're adding to it. We're just, there's lots of things to kind of clean up. But the big thing we added was support for multi-runtime, because we started work with WASM Edge, which is a CNCF project, but we now support a whole, as we're talking about, because things like networking are not standardized, these runtimes have slightly different APIs they've chosen to have. So right now, choosing a runtime basically means choosing the API set you're going to run with, really. Like the actual runtime for the WASM stuff, I mean, it might perform slightly differently if it's different runtime, but the real difference is around the API sets you're providing. So we've offered a choice there so that if you want to run the Fermion Spin runtime, you can run that. And so if you're writing something to target that, but we see that as a kind of temporary thing while we work out the standard API sets so that everyone can run everywhere, because it's long term, we don't want this sort of fragmented ecosystem where you have to think, when you build something, what am I building it for? You want to just be able to run everywhere.
Yeah, that's actually one of the promises of WASM, which I think is one of the most interesting things about it, is this single binary regardless of the platform, right? So you just build a single artifacts basically, and then it would just run anywhere, and that's, I would say, the promise.
Yeah, but because as we talked about earlier, about when you set up your WASM runtime, you choose the APIs you provide. That's the thing they're not the same necessarily, but there's a lot of work going on standardization about how you specify the APIs available. That's the set of APIs, and there's the WASI standardization process and next iterations with more networking, which will meet a lot of the reasons people have diverged in the short run, and potentially you could, although hardly anyone's doing this at the moment, you could write a WASM program that adapts to what is available to it and chooses different APIs.
I see.
But things like that. So there's a bunch of options, but it's all kind of, it's still kind of new at the moment. So people are still...
Yeah, it feels to me like another way of thinking about it is basically you are sort of decoupling the app itself from its environments. Because the way you're describing it looks like you would be able to write your program, And then at runtime, you can define these are the set of APIs I need, or these are the set of APIs available in the environments. And then I can do like file system, network calls, blah, 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 right? So it feels like, it's interesting in the sense that it's still the app itself is just standard. It's like a single app that can run anywhere. And then the app could adapt to environments. Or is it like the other way around?
Well, again, I think that, there's different kind of ways that this might end up. And I think, there's
a lot of speculations here.
But there's a lot of, there's a bunch of work using these interfaces in order to specify, composition of multiple components.
Yeah.
So, you have a component that provides the interface that you attach to the one that requires it. And so, you have this, that's the WebAssembly component model.
Yeah.
And so if your application needs, a database API because it wants to talk to a database, and this application provides that, you can connect them together and they can talk. So there's, that's another way people are thinking about how to use this to modularize components. So it doesn't have to necessarily be that just your app talks to the standard APIs. It could also say, oh, well, I need a Redis endpoint, and someone else can provide it, and so on. So there's a number of, kind of different ways people are thinking about what this might end up like. And, a lot of people are quite excited by the component model. There's a lot of options, again, about what the future might look like. It's still really at this stage where we're exploring, how to build an ecosystem.
Yeah.
And what are the things that make it different and valuable and help developers develop applications more easily using these new capabilities, or how are we going to put these things together? And I think that another thing that we learned at Docker from containers is that a lot of applications are people doing composition of containers.
Yeah.
Docker Compose is
the
name. It's in the name.
I was about to say that.
But a lot of people have these microservice applications that are made up of a number of components that work together. And so again, with WebAssembly, we're thinking like, is that composition, how does that composition fit into the WebAssembly model? What's it going to look like? And I think there's a lot of learning from microservices and containers about, it's part of the reason we're excited about WebAssembly is that we see it very much as a new piece that's in the same space.
Yeah.
And I think that's why there's a lot of, WebAssembly at KubeCon. There's a whole, another
there's
WASM day tomorrow,
right?
but there's a lot of overlap between, the people doing WebAssembly, especially, server side, and the people doing Kubernetes and microservices, and because it is, everyone feels it's a kind of iteration on the same thing. And that's why, at Docker, we're trying to we're still exploring these directions, but we're trying to make a, kind of route for developers to be able to move into the new ecosystem when they're ready and when it's ready for them, and when, so that there's a kind of continuity for developers.
Yeah.
They don't have to kind of suddenly do everything very differently, because I think there are these evolutionary things. There are things that we've learned about using containers and deploying container applications at scale that we're not going to just throw away, because
of course,
there's a change. We're going to keep using these things and evolve them and learn what else we can do.
Yeah, I'm not saying anybody just decided we're just going to rewrite everything in WebAssembly, right? That's not the point. It's like, it's a very early space. And actually, it is one of the reasons why we really want to talk to you or to Docker in general, because like, it's not, when you're looking into the WASM stuff, people are doing a lot of things, but it's not super clear in which direction they want to go. And I think Docker with WASM sounded to me like the kind of one of these like combination of things that make sense for developers, because one of your focuses is the developer experience, right? So I want to touch on one thing, and we can wrap it up. Where do you see all of this fitting within Kubernetes itself? Because one project I heard about is trying to make the kubelet support the WASM modules through containerd.
Yeah,
where you would be able to run.
Yeah, and so you can run that. I think it's available experimentally in Azure at the moment. It's obviously still going through iteration, but that's one way you can do it. And that's, again, that's part of the, kind of seamless transition. You can mix WebAssembly and non-WebAssembly in the same kube cluster,
yes,
and that kind of thing. So there's a very straightforward kind of evolutionary thing. I do get the sense there's some people who think that Kubernetes might not be the best fit. I don't know, it's kind of interesting. I think that, there's some people who think that the kind of niche for WebAssembly is very lightweight serverless stuff, very fast spin up and spin down, very fine-grained serverless, maybe, much more, kind of AWS Lambda style serverless rather than, say, Cloud Run style serverless,
I see, yes.
for example. And I think some of those people think that currently Kubernetes doesn't spin things up fast enough for that kind of work.
It could be slow. It really depends on the use cases. But
it does depend on the use case. But it's not, I don't think my view is that that's not something that can't be fixed. Like the Kubernetes API is very generic. The implementation tends to be kind of slow for lots of reasons that we could spend a lot of time going into. But the API doesn't have to have those properties.
It doesn't have to be container focused. That's what we're saying, right? It doesn't have to be only container.
It's not, it's like, some of the crash loop back off happens a lot. It takes time. It's not required to happen as part of the spec. It's just a convenient implementation, but it happens to add a bit of a latency to starting containers, for example. It's like, sequencing events. And I remember when we kind of had this conversation ages ago when Kubernetes was just taking off, when Mesos, because Mesos was originally a big, came from scheduling world where you spent a lot of time optimizing placement and scheduling, and everyone said that was going to be important in Kubernetes. And it wasn't really important in Kubernetes, actually. Like the developer experience was important in Kubernetes, and the operator experience, and many other things. And so I kind of think that, some of it's just those things coming around again, like what's important and what
are we trying to solve?
What are we trying to solve for, and what's our workloads look like? And if our workloads change the shape that they look like and become a couple of orders of magnitude more, much smaller processes than containers, then we can optimize. We can optimize the runtimes to support those better. But that's not, that's not what they look like right now. And so I think there's still lots of scope for doing work across the ecosystem just to support these different kinds of workloads. And we saw that already with things like Knative and for supporting, serverless type workloads. And it's just like, maybe we need different tools and different work. And so I think there's a lot of evolutionary change that we'll explore around the existing ecosystem and how to move it into new things. And we'll see what kind of WASM workloads people want to run, what kind of things they want to do. It's like, it's the endless variety of what kind of applications do we want to build today?
Exactly.
How do we want to build them? Like, how do we want to, what kind of performance and state management and all the other things do we need?
Yeah. One thing that, and I'm, again, here just like kind of having more like a futuristic look into it, is one interesting...
You might as well be futuristic with the WASM.
Exactly. It's still a lot of it is undefined. So one interesting use case I've been Kubernetes had, and we touched on it earlier, is this problem of multi-tenancy in Kubernetes, right? Like, how do you ensure strong isolation between workloads if they're running on a shared infrastructure? And especially, very importantly, if you are third-party, if you are a serverless provider. So you are hosting third-party code you don't trust on your own infrastructure. And so, because as of now, we don't run Cloud Run on Kubernetes, we're interested on Borg, because Borg has a longer history of isolation compared to Kubernetes itself. So one way I'm thinking about this is you could say to people, like, write your code in whatever programming language you want, compile it toward WASM, and we would take your WASM with all the component system interfaces we've been thinking about that it needs, and put all of that inside a micro VM, like Firecracker or Kata containers or something like that. And then we have these two layers of isolation you talked about. You have the sandbox, which WASM provide. Then you have the micro VM isolation layer. And that way you could potentially have strong isolation on top of Kubernetes, right? That's one use case I'm thinking about.
Yeah, which you can do with Kata containers with containers now.
Yes.
And that was the whole kind of Kata containers original story. And I think that kind of model potentially also works for WebAssembly. I think that, part of it is, again, like, the detail of the kind of workloads and workload provider you want to be.
Yes.
And, what the alternatives are. I think, a lot of people decide that they don't want to solve that problem, they'd rather have Google solve that problem for them. Because
I'm talking about it from a provider perspective.
But yeah, and the providers, I mean, as you say, they tend to not. I don't think any of the large providers do multi-tenant Kubernetes
as far as I know, no.
As far as I know, but I mean, there's other aspects of securing the Kubernetes APIs as well as the VM isolation pieces that you have to take into account. That are also important because obviously the pods have access to the Kubernetes API, so you've got other attack surface other than through the VM.
Yes.
But again, certainly WebAssembly potentially gives you more control over how the networking egresses from the pod. But again, you've got service meshes that can do that kind of thing as well if you want to control traffic and make sure it's not routed into the cluster. It's always routed out of the cluster, or it's controlled in the cluster. But I think there's a number of things to consider in terms of multi-tenant infrastructure's got a lot of things you have to consider, and it's complicated. But certainly those isolation layers, definitely could be part of that.
Yeah. So that's kind of what I was thinking about. Well, one last thing I wanted to touch on is what is the Bytecode Alliance? I read about it a little bit. You are a voting member as Docker.
Yeah. So the Bytecode Alliance is really it's part of the Linux Foundation. It's the standards organization for WebAssembly, because WebAssembly started as a Mozilla project, but it was, from very early on, as we talked about earlier, it was across the browsers. So Chrome and the Google team were heavily involved. So having a standards organization for that made sense. And then for the non-browser parts, those also live in there as well. So it's, and the usual things around trademark and working together in a neutral way and making sure that everyone has level playing field and all the things that the Linux Foundation has done for Kubernetes, NCF has done for Kubernetes as well. But, helping to grow it as a standard platform without anyone feeling that they can't influence the direction and help see where it's going and those things. So I mean, I think that part of standards is sometimes ignored, but it's often it's really important to have a good solid governance behind it. Yeah.
Nice. Well, that actually was an interesting conversation, especially we're talking about something that is still moving, right? It feels like you're basically swapping tires on a car which is driving 120 miles on the highway. So hopefully we will have you or somebody else once there is more clarity about how this whole WebAssembly ecosystem will end up being in few months, years, whatever.
Yeah, no, I mean, absolutely. I mean, it's moving fast. There's a lot going on. I'm sure there's going to be a lot of announcements and things tomorrow.
I'm expecting a lot, yes.
But yeah, I think that, it's an exciting area where there's still a lot of possibilities and I think, that always excites people who want to contribute to something while it's new, while there's the opportunity to kind of make your mark and, lay down the groundwork for something that could go in so many directions and which, I think that there's a growing amount of excitement around the ecosystem that this is going to be an important piece of software going forward. So, it's a great time to get involved.
Yeah, no, it's definitely an interesting space to be involved in if you're looking to, learn something new. WebAssembly it's new to me. I just started playing with it a few months back. Also, as you said, get involved. It's in the Linux space, in the cloud native space, so it kind of follows the same community model as all the other projects. So, thank you very much, Justin, for being with us.
Thank you.
It was a great conversation, and hopefully we'll get to chat during KubeCon this week.
Yeah.
And thank you for listening to the Kubernetes podcast by Google. This is your host, Abdel, and see you next time.
Thank you so much, Abdel, for that conversation about WebAssembly. I first started learning about WebAssembly back when it was still like the JavaScript browser kind of thing that you all talked about in the beginning. I really appreciate that you talked about that. I feel like a lot of folks these days, when they start talking about WASM, they just talk about what it is to them now, which we'll get to in a second, but it's kind of really evolved over time.
Yeah, I felt it was important to talk about the origins because if you were not doing front-end technology for very specific use cases, you probably have never even heard of WebAssembly, right?
Yeah, and the name.
Exactly. I mean, I myself just heard about it. I never used it because I've never done any serious front-end development. Not even like serious in the sense of like having to write code that runs quickly in the browser, stuff like that. I've never done anything. I've done some JavaScript.
Yeah, those types of concerns, not generally our area, but then this WebAssembly thing has just kind of popped up into the containers and infrastructure area from the world of front-end engineering. And so here's what I got from your conversation about that. Mm-hmm. It sounds to me like the way that I explain containers is engineers were trying to find a way to run their code, basically to find a lighter weight packaging and isolation mechanism. We had virtual machines. They work as a packaging mechanism and as an isolation mechanism, but they're pretty heavy. So engineers were trying to find something lighter. They came up with containers, which provide packaging and isolation using C groups and namespaces. And it's basically processes in Linux that just have special C groups and namespaces associated with them to provide that packaging and isolation.
Yeah.
So containers are already pretty lightweight with it being just processes, essentially. But it sounds like from your conversation, WASM is kind of taking that concept of trying to create a lighter weight form of packaging and isolation and applying a very different view on it. And you all mentioned the conversation about it being more similar to a JVM in concept.
Exactly.
It was very interesting to me.
I did some Java development a long time ago. The JVM, and this is something that you only hear if you talk to Java people, right? Uh-huh. When they talk about the JVM, the Java Virtual Machine. I'm not going to pretend to be an expert in Java. Just my kind of recollection of how it used to work is you write Java code, you compile it into what we call bytecode, which is not binary, but not code, right? It's like in between. And then the JVM is the runtime that the JVM itself is dependent on the architecture where you run your application. So there is a JVM for ARM, there is a JVM for x86, there is one for whatever. And then your bytecode will be portable across all the architectures because the runtime is the common part, right? Which is the JVM. And that's where Justin was bringing that analogy from the Java world by saying basically what WebAssembly is, it's kind of like a virtual machine or a runtime. That because like if you read about it, the WebAssembly, I mean, today you have about 40 languages that can actually support compiling a target WASM app, right? So when you compile your app, when you build it, you can set the target environment to be WASM, and it will produce a WASM app. And then you can take this WASM app and put it wherever a WebAssembly runtime is available, and then you can run it. And when you really dig into WebAssembly, it is OS independent or OS agnostic, because basically what you have is like ARM x86, right? So you compile your app to run on ARM and it will run on ARM, doesn't matter where it is, Windows, Linux, doesn't matter, right? And same thing for x86. So that's kind of like the analogy between the JVM world and the WebAssembly world.
That makes sense. Of course, in the container world, there's been a lot of conversations about ARM and x86 and your underlying architecture. But really, the way that we think about containers, we usually kind of stop at the operating system level because that's where the C group and namespace components and the processes all kind of live.
Correct.
So at least when I think about containers, that's about as deep as I usually go. But it sounds like WASM is kind of taking that thinking a step further on how you get from your application that you have written all the way down to the machine code.
Correct.
And it's kind of changing that process. All right. Interesting.
I think WASM is probably as close as we're going to get to the promise of write once, run everywhere.
Interesting.
Because container was supposed to deliver that, but they don't because you still have to...
But it's kind of at the operating system level, right?
Correct.
Like it's different on Windows versus Linux because you got to rely on the C groups namespaces-esque concepts within the operating system.
And it's different on x86 and ARM because you still have to build toward a specific target architecture. I mean, Docker has the multi-arc support, which you can do like one image that can run on both. But this is kind of like taking it a step closer toward, I don't care, there is a WebAssembly runtime, so I'll be able to run my app there, right?
Interesting.
And then there was the whole conversation about the sandboxing, which I think is one of the main kind of like strengths of the technology, right?
Yeah, I was going to ask about that as well. So that makes sense from here's how this packaging mechanism is different from what containers have done and might be very interesting. What about the isolation piece?
Yeah, I mean, as Justin said in the interview, like the browsers in general are the best sandboxing technology that exists today, right? Basically, when you are doing things in your browser, tabs are isolated into individual sandbox processes, right? and one tab cannot access another tab. And if you want to give that access, it's explicit you have to ask for specific requests or specific permissions. So it's not like open by default, right? So an example is when you are trying to share your screen on on like a meeting, right? Like whether you're using Zoom or whatever, you try to share your screen. There is actually a standard set of APIs that allows the application, which is the Meet application or the Zoom or, whatever, StreamYard, Riverside, what we're using right now. It has to implement certain APIs to be able to get access to the tabs it wants to share, right? So that sandboxing environment, sandboxing technology is actually one of the strong points of WASM that people are trying to bring into backends or cloud because it has obvious benefits. I think just taking a step back a little bit here, it's very interesting. Something just popped in my head. Mm-hmm. So containers does the packaging stuff and they do isolation up to a certain level. Good. Now, although containers don't do full isolation, they do a little bit of isolation. Cloud providers like us, like Amazon, like all the other ones, when they allow you to run apps on their infrastructure, they do not use containers, right? Like Amazon had to write a micro VM firecracker to be able to support Lambda, right? Which is not a full VM and not a container, something in between. So I think that the sandboxing technology that WASM allows is a very obvious feature that a lot of people need, at least from the cloud provider's point of view. Allow people to run random code in your environments. That's one of them. Or if you care about isolation on your infrastructure between your tenants, for example, you still want to use the infrastructure shared between a lot of tenants, but you want to have strong isolation between them. So despite it being a lot of undefined and open question stuff that we have discussed in the interview, it is a technology that has a lot of good stuff in it.
A lot of promise here.
Yes.
I think there's, like you said, the next several months of development in the WASM world will be very telling. I look forward to it.
Exactly. And there is a conference that we have covered in the news in September, Bellevue, Washington. So there is WASMCon. I think it's going to be probably the first edition because they used to do WASM Day, or they did WASM Day in KubeCon EU this year.
Yeah, I definitely think I'm going to try and check that out.
Yeah, and there is quite a lot of things going on. Just go ahead and Google WASM and you will be flooded with the amount of stuff that pops up. One other thing also that was interesting to me, at least, and this is funny because I had this conversation with Justin, back in April. And then, we went on and we did a lot of other stuff and things like that. And last week I was in south of Sweden and I was having a meetup. So I ended up meeting a person who open sourced and maintained a tool, which what it is essentially, it's a distributed caching tool for Kubernetes, right? So the way it works is that it installs itself as a daemon set on all your nodes in the cluster, and it caches images. And it acts as a proxy. So when a node is trying to put an image, it will proxy through that tool, and that tool will pull the image from another node if it's available there before it goes upstream to the container registry. It's using containerd. And so he was like, it's using containerd. And I was like, I've been seeing a lot of things using containerd. And then I remembered that Justin said that containerd is just a generic runtime environment.
Yeah. Everything uses containerd.
Which I haven't thought about it. It's kind of funny. So yeah, I just mentioned this because it's another topic I want also there are a few people that we would like to have on the show to talk about containerd actually.
Yeah. We'll have to look forward to that in the future.
Sounds good.
That brings us to the end of another episode. If you enjoyed this show, please help us spread the word and tell a friend. If you have any feedback for us, you can find us on Twitter at KubernetesPod or reach out to us by email at kubernetespodcast@google.com. You can also check out the website at kubernetespodcast.com, where you'll find transcripts and show notes and links to subscribe. Please consider rating us in your podcast player so we can help more people find and enjoy the show. Thanks for listening, and we'll see you next time.